Flipping physics! Ah!
What's up, ladies and gentlemen, people? Today we'll be looking at different densities of different sports balls and how it affects their velocities, energies, and max heights. And at the end, we'll have a little spice of physics, you know? But before we get to that, let's head out into the field with Dangerous Dan and get crack-a-lackin'.
For the record, I'm done trying to make y'all comfortable. For the record, you ain't trying to grow, then it's done for you. For the record, lab on me going all the way. For the record, ain't trying to link, no time to waste. For the record, for the record, yeah. For the record, yeah. For the record, yeah. For the record, for the record, yeah. For the record. Been a little too nice to y'all. Now I gotta up price for y'all. Snake eyes on dice for y'all. Shoulders on ice for y'all. Frozen. H6 all the hate. I won't get involved today. Got lost in the ball and age. I'm flipping the bars and flipping the on record, off record. I still count wins when they doubt it. On record, off record. I let them take advantage. I was wildin' on record, off record.
Thank you, Daryl. Now we're out here at the baseball field gonna hit some baseballs. Want to show me what we're hitting? Got a baseball, softball, fancy softball, and a tennis ball. Back to you, Daryl. God, I hate my explosives.
I don't know what the last bit was about, but thanks anyway, Dan. Now, as Dan said, we have 4 different types of sports balls: a baseball, softball, fancy ball, and tennis ball. Now, let's take the time to figure out the densities of each ball. Does anyone know how to do that, class?
Don't you just take the mass of the ball and multiply it by height?
No, silly goose. Density is the relationship between mass and the substance and how much space it takes up. The formula is D equals M over V.
Perfect. Thank you, Matt. Now, does anyone know how to find the volume of a sphere? Mason?
Isn't it just volume equals 4/3 pi r cubed?
Indeed it is. The volume of a sphere, V equals 4/3 pi times r cubed. And the density of anything is M over V. Now, with this information, we can figure out the determine the densities of each ball. So, alright, now we have all the densities figured out. We have a baseball, softball, fancy ball, and tennis ball. As we can see, the baseball is the highest density, which we probably figured. So class, now what can we do?
Well, from going to the field, we collected the data using a stopwatch and tape measure to get the distance traveled and time it took for the ball to reach its final destination, right?
Correct, Matt. We did get the time and the distance traveled for each ball. For the baseball,
Yeah, and we totally got that initial velocity from the super cool and environmentally friendly Lugger Pro doohickey.
spot on. We'll write down each initial velocity for each ball now. Alright, now with this information, what formula will we use to figure out the final velocity? There's 3 we can pick from, so choose carefully.
Looking at the formula sheet, thing seems the easiest one would be the first formula because it's shorter. It reads out velocity final equals velocity initial plus acceleration times time. Plus, you don't even need the distance, idiot.
Alright, yes, but please watch the language. So now we've got the formula we need, we've got the numbers, I think we're ready to start.
Wait, I hate to ruin the vibe we got going on, but how in God's green earth do we know the balls were hit the same way? Like, wouldn't that change all of the data we collected up?
Good question, Jake. I'm glad you asked. And you're in luck, because our very own Dangerous Dan is here to answer your question.
Well, you see here, Jakey, we've got a little instrument called the ZEP, and it reads bat speed, vertical angle, and attack angle. And with years of hitting experience, one can hit a ball 4 times to get those 3 things close enough with a margin of error, of course, where the balls aren't affected.
What exactly is the margin of error, sir?
Well, you see, for each specification it was different. We gave the bat speed 5 miles per hour wiggle room, the vertical angle 10 degrees, the attack angle 5 degrees. As you can see here, 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 and here.
Wonder where he went, but anyhow, we got the question answered. I think it's time to start the equation. So, I'm going to use VF equals VI plus AT. So as you guys can see, I got 33.21 meters a second for the baseball. Jake, what'd you get for the softball?
For the softball, I got 36.18 meters per second.
36.18 meters a second. Mason, what'd you get for the top tennis ball?
With tennis ball, I got 30.61.
And Matt, what'd you get for the fancy ball?
For the fancy ball, I got 27.34 meters per second.
Thank you. So now we got all the numbers here. We can see that that the softball had actually the highest final velocity, which could contrary we think the baseball would. But that was probably comes from the fact that the bat speed was actually faster for the softball. So we can take that into account and probably assume that the baseball has the highest final velocity per bat speed hit. Now, does anyone else know what we can do with these numbers?
Well, according to my hypothesis, I think we could try and find the max heights and the energies of the balls.
Correct. Mason, do you have any ideas on how to figure out the energy or max heights of the balls?
I think you can figure out the height by using this second formula of kinematics, which is displacement equals the initial position plus the initial y velocity times time plus 1/2 times the acceleration of time squared.
Very good. Let's go ahead and start doing that. I'll do the max height for the baseball. You guys each do your own max height for the balls you did. I'm going to erase this work because we don't need it anymore. And make sure you don't forget to include the height of the tee, which is 0.767.
Is that in meters or feet?
It will be in meters. Alright, so I got 5.06 meters for the baseball. Jake, what'd you get for your softball?
I got 4.4576 meters.
4.4567 meters. Mason, what'd you get for the tennis ball?
I got 12.5776.
12.5576. And then Matt, what'd you get for the fancy ball?
I got 5.3776 meters.
Can you repeat that for me, please?
5.3776 meters, sir.
Sorry, you have a really hard accent. Anyway, now we have the numbers here. We can see the tennis ball actually at the highest, which we can see the numbers are kind of bouncing around different places, but that can be due to different errors between the spring compression of the ball and the difference between the bat attack angle and vertical angle. Alright, now let's move on to the energy of the ball. More simply, the kinetic.
Actually, Professor, I said 12.5776 meters.
My bad, Mason. I'll fix that for you. Alright. So, the kinetic energy, who knows how to find it? Jake, do you?
I think it's what, MGH?
No, you clown. The equation is kinetic energy equals 1/2 mass times velocity squared. Idiot.
Perfect, Mason. Kinetic energy is 1/2 mv squared. I'm going to erase this because we don't really need it anymore. And I'll calculate the kinetic energy of a baseball while you guys calculate the kinetic energy of your balls. Alright, Jake, what did you get for your softball?
For the energy of the softball, I got 130.899 joules.
130.899 joules. Mason, what did you get for your tennis ball?
I got 26.23 joules.
And Matt, what did you get for your fancy ball?
According to my calculations, I got 56.81 joules, sir.
Alright, thank you. As you can see, the softball has the highest amount of kinetic energy, which makes sense because it has the highest mass. So as you see here, we have a lot of joules. But remember, don't joule, it's not cool.
Seems cool. Professor Darrell, I was wondering if we could figure out the bat speed after impact.
Nah, man, peace and love, but no way. You cannot find that.
Actually, we can. To the left! for baseball. So with the research done, I think we can finally figure out the speed of the bat after impact. Theoretically, of course. Using conservation of momentum, in theory, we can figure out the speed of the bat after impact. Does anyone know the equation for momentum?
But Professor Darrell, isn't it just the mass times velocity of the bat initial equals the mass times velocity of the bat final plus the mass times velocity of the ball initial?
Correct. Let's figure that out now. We know that. So after we do the math, it comes out that the speed of the bat after impact is 22.765 meters a second. So that means the bat slows down by about 7 meters a second in the time it goes from hitting the ball to after hitting the ball. We're coming to you guys the day after class, and thank you for watching the video, and we'll see you next time on the next Living Physics video. Woo!